Hello. Today in this video we're going to be talking about geometric series and how to determine whether or not a geometric series is convergent, divergent, and if it is convergent, how to find its sum. So let's start off this video by reviewing what our definition of a geometric series is. We know that a geometric series is any series of the form a times r to the n minus 1. And what this means is that it can be written out as like a partial sum, starting with a, and then for each following addition, we're going to be seeing that each a is going to be multiplied by another like factor of r. So we're going to be a plus a times r plus a times r squared. So a times r was multiplied by another r to get a times r squared, and so on into infinity. And we know that this series of this form, geometric series, is convergent if once we identify our r, it is the absolute value of the r is less than 1. And when that happens, we know that our sum is going to equal a over 1 minus r. However, if when we identify our r in our geometric series, it's greater than 1, we know it's divergent. So let's start off with an example, an easier example, and figure out whether it's convergent or divergent. So let's start off with the series right here. Let's write out kind of how our definition is, a set of partial sums to kind of get in a feel of what this series is doing. So first we're going to have e, we're going to have an e to the first power, because our n is going to be 1. All over 3, 1 minus 1, which is going to be the same as e to the 1 all over 3 to the 0 power. Our next term is going to be e squared all over 3. N is 2, so 2 minus 1. So that's going to be the same thing as e squared all over 3 to the first. Our next term, I'm just going to keep doing this out for a couple terms here to see what we get. E cubed. We get 3 to the 3 minus 1 power, which is the same thing as e cubed all over 3 to the second power. And let's do one more. And e to the fourth power, n equals 4 here, times 3 to the 4 minus 1, and then we're going to go into infinity. So we're going to get e to the fourth all over 3 to the third. So now we need to identify what our r is and our a. So in this problem, the thing we start off with in this first term here, all by itself, like our definition shows over here, our a is the first term. So e over 3 to the 0 is the same thing as just e. Now our r is what's multiplied to each consecutive term. So we can see that in the second part, e is multiplied by an e over 3. In this third term here, you see that it's multiplied by the same thing. E squared times e is e cubed. 3 times 3 is 3 squared. So our r is e over 3. Now, to determine whether or not we have convergence or divergence, we have to take the absolute value and determine whether or not this is less than or greater than 1. So, in this problem, we know it's less than 1, and that therefore it converges. Since it converges, we can find its sum. So the definition of our sum, like we said over here, is the sum of this series is going to be equal to a over 1 minus r. So here we know that our a is e, and we have 1 minus our r, which is e over 3.